power system. So today experiment is basically about the power flow. Okay, so the objective is basically to do the power flow study to uh, uh, by using some particular tasks. Okay, so here we have two tasks. Okay, one more thing is kindly open the recording. Okay, okay, it's already started recording. Thank you. Okay, so uh, the task 1 contains 40% and task 2 contains 60%. Okay, so for task 1 uh, we need to use this particular file. I think you already been downloaded. So for we'll use this particular file, and then you need to simulate power flow. Okay, and you have to analyze some particular parameters, these particular parameters, and these particular parameters cannot be less than plus minus 5%. Okay, and this loading parameters cannot exist more than 100%. So once you do the simulation, you need to look very carefully about those two parameters. Are those in the consideration or not? Okay, so this is the task 1. So I just straight go to the PowerWorld file and see. Okay, this is task 2. I am now opening task 1 now. Okay, so this is the lab 3 task 1 first file for the task 1 file. Okay, you can see that this is a very you can see that this is a very complicated network where you have lots of gen buses, transformer. This is the utility. Okay, so you have lots of things. So you have to run the power flow and need to analyze uh, some particular parameters. Okay, so how you can run? There is option play. Okay, so just play, click the button. Okay, so you once you zoom the diagram, you can see that there is a power flow is going. One is the real power, another flow is for the reactive power. Okay, so the power flow is going one bus to another bus. Okay, so the real power and the reactive, everything is going. Okay, so now you need to analyze those particular things. Okay, those particular things. So just stop. Under the tools there is option model explorer. Okay, model explorer, just click it. Okay, so now our consideration is that it should not be less than plus minus 5%. It means the per unit values should not be less than 0.95%. Okay, so those are the all buses. Okay, so this those are the per unit values. Okay, so this is the lowest one and this is the highest one. So you don't have any buses which are experiencing the highest less than 0.95, because the lowest one is 0.96. So there is no bus which is experiencing lowest less than 0.95. Okay, so it's okay with that. So in your lab report you have to write down that which one is the highest buses and what's the per unit voltage, and which one is the lowest one and what's the value of the per unit. So if it's in the range, then it's okay, but once it's not in the range, then you should try to improve and make it to the 0.95. But in that case all are in the range. Okay, now I am going to the next part, which is the 100%. The loadings should not be exceed 100%. So how you can see, there is option branch state. So you see the percentage of MVA limit. Okay, so this is the highest MVA limit for the bus number 28, which is 95.6, and this is the lowest one, which is 0. So no bus MVA exceeds 100%. All are in the range. We don't have any issues so far. But once you have any issues, then you need to uh, improve it. Okay. So this is the task 1 we have. Okay. So this is all about your task 1, where you need to just run and you need to simulate, and then you need to calculate, you need to analyze that if it's in the range or not. If it's in the range, then okay. Okay, then the task 2. Okay, so in the task 2 they said that you need to use this particular file, and again you need to do the same thing. See, the same thing to the task 1. But they also say that if there any per unit voltages buses which are experiencing the lowest voltage, you need to improve it. And for improving, uh, you can add a new device, or you can change the tap position, or you can change the generator voltage set point. So you have lots of methods. Okay, so now I am opening this particular file, lab 3 task 2. Okay, so this is the task 2 file. Okay, so can anyone tell me what the difference between the task 1 file and the task 2 file? Anyone? Any difference? Have you found? No one?
Not sure, sir.
Yes. Yes.
No, we are not sure.
We're not sure. Okay. Okay. Just see. This is the task 2 file. Okay. And now I am opening the task 1. See. This is connected here. This particular generator is connected here. This is the red button. See. Now I am opening this one. You see, this one is open. So in this case, this one is open. So there should be some influences, all buses. And also you can see they said that outage generator of Gen 1. So outage means it's not in service. This particular generator is not in service, it is in outage. Okay, so you have to find out uh, you know, particular diagrams difference, otherwise those are the fundamental things. Okay, so before that I'm just deleting all the data, so I'm starting from the reset. Okay, now start. You see the power flow is going on. The power flow is going on. Okay, so now let's analyze. Okay, so now we have lots of buses which are experiencing very low voltages, less than 0.95. So particularly those buses, experiencing lowest. And for this, number 22, bus number 22 is experiencing very low per unit, 0.92, because our limit is it should not be uh, it should be in plus minus 5%. So plus minus 5% is 0.95. So those buses are what they call experiencing lowest per unit. So now you need to improve it. Now let's see the second one, the loading. Okay, so loading is okay here. Highest one is 95.6 and lowest one is 0. So loading has no issue, but the per unit voltages has some issue. Now you need to improve it. So bus number 22. So any idea how you can improve per unit voltage? This is bus number 22. You see 0.92. Any idea how you can improve the mm, the lowest per unit? The how you can improve the value? Any idea? Anyone?
Improve efficiency.
Improve efficiency of for what? Which
Uh,
device?
that one I'm not
Generator,
sure.
transformer. Okay, but you can see they already said that what you have to do. They said that you can add a new device. Okay, and also you can change the tap position of the transformer, or you can change the generator voltage set point. So the answer is already there. This three line is the answer. Okay, so you know, you have to understand all those things. Okay, so first of all, you can change the generator tapping ratio. Second one, the first one is you can add any device. Anyone have the idea which device we can use? As you already done the lab 2, it is related to the lab 2. Anyone? Any idea how to improve or how to control anything? What we actually use?
Capacitor.
Which? What?
Capacitor.
Capacitor. Yes, shunt capacitor. The shunt compensation. Okay. Yes, the correct answer. Okay, so you can also improve by using shunt capacitor, but it is economically I don't know is it feasible or not, because you have to study, because they also said that uh, it should be in economical way. Okay, another thing is generator set point, but unfortunately this generator is not in service. Only this generator is service. This is the utility slack one, so you can change it. So you can change the set point from here, but I'm not sure by changing this particular set point you will improve, you will be able to improve all the lowest experiencing buses. I'm not sure. So I don't know that it will be feasible or not. Okay. So last one is that uh, the transformer. Okay, last one is that the transformer tapping ratio. Okay, so now let's see this bus number 22 has the value 0.9283. Now I am changing the transformer tapping ratio. Just I am double click transformer. Let's see transformer. So this is the tap ratio. Now it is 1. You have to decrease. You have to decrease like one tap. So one tap is 0.625. Let me check. One tap is yeah, 0.0625. Okay, 0.0625 is one tap. So I am now decreasing one tap. So 1 minus 0.0625. Just calculate it. 1 minus 0.0625, which is 0.9375. Okay, 0.9375. So this value is by decreasing one tap, 0.9375. Okay, so click it. Okay, so this is 0.92 now. So now run. You see, it's increased. It's now 0.99 and it increased very uh, uh, in high number. Okay, 0.9986. Okay, before that it was 0.92. So you have also buses like now this one is the second lowest one, which is 0.93169. So by this procedure you have to improve all the buses, and in your lab reports you have to describe all those things, that which methods you are why you are interested, tapping ratio, why not the generator set point, why not the capacitor one. You have to analyze all those things and which method you will going to be implement. If you implement transformer tapping ratio, then let's see that what is the tapping ratio. Okay, so why it is economically beneficial, because we have lots of transformers, so it is easy to control. Okay, so yes, this is all about our lab 3. Okay, so this task 1 and this one is similar, but the diagram is different, but the uh, you have to do the same thing, but the only difference is the number 3, where you need to improve the per unit voltages. Okay, so any question?
Sir,
Yes.
can you explain again why we need to minus the 1.05
Yes,
where
sure.
the
Sure.
value of 0.0625?
Yes, it is before it was 1,
Mm-hmm.
correct? So
Yes.
if you want to, this is the tapping ratio. It means you have a transformer, primary side and the secondary side. As you know, transformer has two types of transformer we have: step up or step down. Okay, step up or step down. So here, if you want to improve the value, you need to decrease the turn ratio. Turns means the wire, the spinning wire, spiral wire, which is actually connected with the body of the transformer. Okay, so here, if you want to decrease one tap or one what they call the one turn, which is the value is 0.0625. So before that it was in full turn, which is 1. Now I am decreasing like 1 tap, which could be like 25% or 50% could be the if you change 2 tap, but or 3 tap or 3 taps. Okay, but if you want to decrease only 1 tap is equal to 0.0625. That's why I am subtract 1 minus 1 tap. It means the full turns of ratio minus 1 tap. Full turns is 1 and 1 tap is equal to 0.0625. That's why I put the value 0.345. Suppose if you want to decrease 2 tap, so what would be the value? The value would be 0.0625 into 2. So it should be 0.125 if you want to decrease 2 turns. But fortunately, once you decrease 1 tap, our desired thing happened. Like we want to increase this value, so it is already happened. Okay, so we don't go to the second tap. 1 tap, decreasing 1 tap, it is okay. Is it clear?
Yes, sir.
Okay.
Yeah.
Okay. Yes, 1 tap is equal to 0.0625. Yes. Okay. So any other questions we have? Any questions for anyone?
Sir,
Yes.
just to confirm that just now you said that for the difference between the task 1 and task 2 is that the generator in task 1 is connected and the task 2 is not connected, right?
Right. Not connect. Open.
Okay.
Right. They also said in the manual. This one. The outage. Outage of the generator Gen 1. This is the Gen 1. See? Okay. So any other questions? Then we will go to the rubric part one by one. Okay. So I am now stopping from my side. Uh, okay. So now I'll go to the rubric. So this is A7. Okay. So Rais Hamizan bin Mahmad Tarmizi. Okay. So kindly just demonstrate us the task 1. Okay. So just first simulate the file and see your per unit voltage is what, which is the highest one, which is the lowest one, and what about the loading, which is the highest one, which is the lowest one. Okay.
Okay, sir.
Yeah. Just share the screen and just tell us.
Ready, sir?
Uh, Still your screen is showing.
Sir, can you see the
Not yet.
not yet? Wait.
Just reshare.
Uh, does it show already, sir?
Mm, not yet.
Not yet. Wait. We'll try again. Now, sir.
Uh, Not yet. Yes, now I can see. Yes.
Okay. So, for task one, mm, so can you repeat again? What to compare?
Yes, you just need to see your if your any volt per unit voltage is less than 0.95 or not. Okay, and
Okay. And
your loadings is not, it should not be exist 100%.
yeah. So for task one, the per unit value, uh,
Which one is the highest one?
uh, bus number one.
There is an option to see the highest one and the lowest one.
Oh,
Uh, just click the per unit uh, column,
okay.
the upper one, the
Oh yeah.
upper.
Oh, okay. This one.
Yes. So which one is the
So
highest
bus number one.
and which one is the lowest?
The lowest
Uh,
is
you can
bus
also
number
see
four.
from the lowest one. No, no. There is option to see the lowest one also. Just click it and
Or just click it.
yes.
Here. Oh, sorry. The highest one is bus number one, and the lowest one is bus number two.
Okay. So is there any bus which is less than 0.93, 0.95?
No, there are no bus less than 0.95.
Okay. So now just show the loading section. How you can show see the loading?
Uh, you have to click the model explorer, right side.
Yes. Now which tab you need to use for see the loadings?
Wait. Um, should be right here.
Yes.
This one, right side.
This one is for bus, but
Uh, I just see just now that you click somewhere. Here.
okay, it should be branch state. Just see in the left there is option branch state.
But
Just upper on of the buses, the option
this
bus.
one. All right.
Yes, branch state. Now, which column?
This one, sir.
Which one?
See this one.
Uh,
Uh,
You're maybe yes, this one, right? Yes, right. So which one is the highest one?
bus number 28.
28. And which one is the lowest?
The lowest one is bus number 29.
Okay. So is there any buses which exist to the 100%?
No,
No.
no.
Okay. Okay. Thank you. Thank you,
Okay.
Rice.
So,
Okay. I'm giving you full marks, but try to follow every steps. Okay. So next is Muhammad Salman Farhan bin Muhammad Sufyan.
Yes,
Yes. Okay. So just do the same thing that your friend did. That for the task two. Okay. The task two.
you can see my screen.
Not yet. Maybe it's coming.
You can see, sir.
Not yet. Maybe you need to reshare it again.
Um, Not yet.
Not.
Let me stop and share again.
Yes, yes.
You
Yes, now
can
I
see
can see.
now.
Yes.
Uh, so
Okay.
first,
So first tell me that what's the difference of the diagram task 1 between task 1 and task 2.
different is the generator one is not connected. It has the outage. It's
Outage, okay.
different.
Is it
Uh,
it's for the task 2?
task two different
Okay.
between task one and task two.
And okay, and in task 1 it was connected.
Yeah.
Okay, that's good. Okay, so now run the power flow.
Um, you want me to open the model explorer, sir?
Okay.
What? Here at buses, we have to compare the power
Okay.
unit voltage between the
Okay, fine.
highest and the lowest.
So is there any buses which is experiencing 0.95 less than 0.95?
Here,
Yeah. How many?
0 point up until here, 11.
Okay. So which one is the lowest one?
The what?
The which one is the lowest per unit voltage?
The number one.
The number one, the bus number 22.
Oh, the one.
Okay, and which one has the highest one?
This one
Bus number 4.
is, yeah. See.
Okay, it's 1. Okay, okay. So now just there's some issues in your bus as we have some buses less than 0.95. Okay, so now let's go to the checking for check to the the loadings. What about the loadings? Is it okay or not? How you can see the loading? Yes.
VA limit.
Okay. So which one? Which one is the highest one? Which bus? How you can see that? Yes. So which bus? You think? Yes. Bus number 28 and bus number 30 has the same value, 95.6. Why you highlight 35.3?
Oh, no.
Uh, okay. So maybe you have some lackings of knowledge. Okay. So okay. So which one is the lowest one?
The worst one.
How you can see the lowest one? This is the highest one. Okay. Yes. So which one is the lowest one? Mhm. Zero? Is it zero? Have you find out? Okay. Okay, I'm telling you. The lowest one here actually is zero, and the highest one is, from your case, it was 95.6. So our aim is it should not be exist 100%. So we are not interested in the lowest one, but we are interested in the highest one, and the highest one is 95.6. Yes, just click it. Yeah, 95.6. Yes. So this is the thing. Okay. So thank you, Farhan. Okay. So I'm just giving you. Okay. Okay. Next one is Mahmoud Faris bin Azmi.
Yes, sir.
Yes. So just as your friend did that, you have he got some values. He got some buses values which are experiencing less than 0.95. So can you
Yes.
improve the any for the most lowest bus, like bus number 22?
All right,
Can you
sir.
improve the value? Yes. Just share the screen.
Okay, wait a second. Can you see my screen now?
Oh, not yet. Maybe it's coming.
All right.
maybe you need to reshare because it's still not coming.
I'll share my screen.
Okay, yes. Again, reshare. Okay.
Is it sharing now?
No, not yet. It's coming.
I'll do it again one more time.
Just share. Yes, but yes, I can now share your screen.
Okay, is it sharing now?
Yes. Yeah.
Okay. So first I will run my simulation. Stop it.
Mhm.
So the lowest value is for bus number 22 of 0.928, which is
Right.
less than
Right.
0.95.
Yes. Try to improve
So
it. Yes.
there's three ways of changing it. By adding new device, changing the transformer tab or generator. So for this one, we'll change the transformer tab. So this is bus number 22 with 0.92. So we'll change transformer tab over here.
Hmm.
One transformer tab is equal to 0.0625. So if you want to change one tab, 1 minus that value, which is
Right.
0.9375. Then
Yes.
I will run it again. So here we can see that the value is more than 0.95 now. So it is plus minus 5% from 100%, from 100 to 1.
Yes. So it's improved.
Yes, it is improved.
Okay. So it's improved. That's good. Okay. So thank you. Thank you, Faris. Okay. So next one is Tazul Abdul Aziz bin Tazul Urus.
Yes, sir.
Okay. So you just need to improve another bus as your friends did. You just need to improve the second bus. Share your screen
Can you
and try to
see my
improve.
screen, sir?
Not yet.
Now, sir.
Not yet. We need to reshare. Yes, I can see now.
Ah. So for the second one,
Mm-hmm. First, open the model explorer. Yes.
So the second bus is 17.
17. Yes, 17. Okay. Just
Uh,
open.
Seventeen. 17. This one. So we change the transformer ratio.
Okay.
1 minus with 0.0625, we get 0.9375. So here we can see that the power unit voltage has improved for bus 17.
So before changing, what was the value?
Uh, 0.93.
And now it is 0.99.
Yes.
Okay. 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 Thank you.
Yeah,
Thank you,
thank you, sir.
Tajul. Welcome. Okay. So next one is Tuan Ahmed Adam B. Tuan Zamri.
Yes, sir.
Yes. As your friend did that, your two friend did that. Two buses they have successfully improved. So now you just improve another bus.
Okay, sir.
Okay. So just share the screen.
Can you see the screen?
Uh, just wait. Not yet.
Yeah. Can you see the screen now?
Yes.
So the third bus is 39.
39. Okay.
So so 39. You need to change the transformer ratio.
Okay. Which one is the 39? Can you zoom it so that we can see?
This one.
Okay. Okay. Yes.
So change the transformer ratio. 1 minus 0.0625 equal to 0.9375. So the per unit voltage is now 0.9983, more than 0.95.
Okay. So before changing, what was the value?
0.93 something.
93. Okay. So now it's 0.99.
Yes.
Okay. 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 Thank you, Tajul. Sorry. Tuan.
Adam, sir.
Tuan Adam. Okay. Sorry. Adam. Yes. Okay. So do you have any questions regarding lab reports or anything? Any guys?
Yes, for lab report, what kind of result do we need to compile? I mean, what is the
Okay.
result that we need to write?
Okay, so first task one and task two, you just need to write down the analysis. Okay, first you have simulate the diagram, and you have to first analyze is there any value per unit value which is less than plus minus 5 or not. If it's not, then first you should say that there is no buses which are less than 0.95. So after our deep analysis, the the highest bus per unit voltage is this, and the lowest one is this. Okay, then for the second, what is the loading one, then you should write that there is no, first you need to check is there any buses which exist 100% or not. If yes, then you should write yes, or if it's no, then you should write that there is no buses which is exist 100%, but the highest value is this one. That's okay. Then this is for the similar task 1 and task 2. And for the task for the improving, here you have to analyze some things like they said that you have three methods for improving the per unit voltage. One is you can add any device which is shunt compensation. Another is you can change the generator setting point, and third one is the changing the tapping ratio. So you need to analyze, and you need to say that which method you will going to implement and why from the economical aspect. Okay, and another thing is that after changing your tapping ratio or anything, how much you improved, what was the previous value, what was the current value. Okay, so just you need to analyze those things. Okay, is it clear?
Yes, sir, it's clear. Thank you.
Okay. So okay, if you don't have any questions, then we can end the session. Okay.
Thank you, sir.
Okay, thank you guys.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Okay, thank you. Bye bye.
Bye.